Let's try to answer some questions. Why knowing Bash is so helpful? Who and why uses it? Is Bash scripting a rocket science that can be done only by top qualified superheroes? To answer those questions, we will take a look into a few scripts for the time without a deep understanding of each and every command. Please note that multiple commands that you will shortly see repeat in the script over and over. You can review those scripts again after finishing the course, and I am sure you will feel the difference. Let's start in etc. Among other files, there is here a profile file. This file is a script and it's executed each time when the user logs in into the system. When you log in to Linux, when you open a new session, then at the very beginning something happens. You may see on screen some messages, but that's not the most important part. In background, a lot of environmental variables will be defined, some aliases or functions will be created, and so on. A lot of those tasks are done in this particular script. So what we have here? Some lines are preceded with hash sign. Hash is a command. Whenever a line starts with a hash, it will be skipped during execution. Comments are for us, people who develop or review the scripts. We can better understand the idea of the script having comments. The next part is a function. The function has a name. In the curly brackets there is the definition of the function, sometimes called the body of the function. This code will be executed when the function is called. In the function body there is a case expression analyzing the path variable. Few lines below there is a conditional statement, if. The condition after the word if is, at least strange. Square brackets, dash, x, user bin ID, but no worries. That's something what you will shortly understand. Scripts need sometimes to take decisions. This is done with the help of the if statement. Maybe you already noted that a lot of text here is written with capital letters. That's just an old standard that variable names are written in capitals. If you decide to use small letters, no problem. All will work. Instruction like log name equals $user assigns the value of the variable user to the variable log name. The sign $ means we want to get the value of the variable. The value of the variable can be also set differently. Here, the variable gets value from the result returned by the id command. Note that the command is put into a reverse apostrophe. That's strange, but no worries, we will discuss it. As you see in the next lines, we have again a comment, if statement, variables, if else, and finally something new, the export statement. Export publishes the variables so that they will exist also in the child processes of this one process. Thanks to the export statement, each and every of your sessions know what is path, user, log name, mail, and so on. Here we have the first loop. That's a for loop. Here a specific action will be taken for every file with the extension sh in the folder etc profile D. That was just one example. Of course, other scripts may do something quite different. They may guide you over the software installation process. Such a script would surely ask you for some details and later would copy files, add up the configuration files, and so on. All depends on the task that the script authors wanted to achieve. Let's look into the sbin directory. Here you can find binaries of programs dedicated for sysadmin. There are many files here. Which of the files here are scripts and which are pure binaries? To check the file content, we can use the command file. After typing file, type the name of a file that should be checked, and as a result, we will have information displayed on screen. This file is a binary. And what kind of a file is the already known to us etc profile? It was recognized as just a text file. And what is the service file? It's a bash file. If we want to display only the files containing scripts, we can use following instruction. Check type of all files using the file asterisk and show only those identified as scripts. That's the list of such files. Some of the files are Python scripts, the other are shell scripts. But wait a moment. How the file command detects the type of the analyzed file? Let's check one of the shown here files. We will check the content of the file. Look, the first line is very specific. On one hand, this is a comment only. It starts with hash, but after it we have exclamation mark and path to a shell that will be used when executing the file. That's the information checked by file command that allows to categorize the files. In other file, for example tuned, we can see that the first line looks a bit differently. It points to Python interpreter. This first line is called shebang and it's used by operating system when starting execution of the file. Depending on the pointed here path, the file will be executed as a shell script or Python script or something else. So in this way, we have learned the first command file, which checks the file type. In this lesson, we have discussed why and how the scripts are used. You were able to see that the scripts contain just repeating commands like if, for, case. However, the syntax may be strange. Indeed, bash may behave differently if you accidentally skip or add a space. So we will need to learn the syntax of those statements. We learned also instruction file, allowing to check the file type of a file found on the disk. In the next lesson, we will develop our very first script.